So till now no one joined, so I'll wait another 5 minutes, then I'll explain then I'll start the session. Okay, so now I'm going to start. I think no one will join, or if join, so we'll see. But now I'm going to start the first question of week 5. So the question first is, okay, let me just, yeah. So the question first, a cylindrical tank of height h is filled with water up to a height h by 2. the pressure at the bottom of the tank is. So in this question we need to calculate the pressure at the bottom. Pressure at the bottom of the tank. And here you have one cylindrical tank. Remember please, the cylindrical tank is like this. This is your cylindrical tank. And the total height of this tank is h. Total height is given and the water filled up to half means here. H by 2. Now we need to calculate the pressure at this. So how the pressure vary? The pressure variation is linear. Variation is linear means pressure P is rho g h. Now here question is the pressure at the bottom of the tank. Okay, I think the Mukesh Kumar has joined. So Mukesh, am I audible? Please just you can write in the chat box also. Okay, thank you. So the question 1 is visible. Question 1. Mukesh, question 1 is visible. Okay. So here I am explaining the question 1. So I am solving. So once I'll solve, then from question 2 you take attempt for solving, right? So I'll give you minutes. So the question 1 is you have a one cylindrical tank of height h filled with water up to height h by 2. The pressure at the bottom of the tank is. So at the bottom level you need to calculate the pressure. So what will be the pressure? This is your pressure. Pressure variation is pressure vary linearly, so rho z h. Now here one thing I think question is missing here. If you are going to calculate the gauge pressure, the rho g h will be the correct, or that is if the height is h by 2, so P is equal to rho g h by 2 will be correct. But if you are going to calculate the absolute pressure, so you need to add the atmospheric pressure also. So in this question, the asking the atmospheric pressure or detail your not gauge pressure, so that's why option D is correct. So detailed solution is there. The pressure at the bottom of the tank is due to the water column above it, given that the height of water column is h by 2 and the pressure at the bottom is. So here the solution is given similar, just written rho g h. So if h is h by 2, so h by 2 and your atmospheric pressure. So this is your absolute pressure. Remember, if rho is the density of water and g is the acceleration due to gravity and P atmospheric is the where is, here is where rho is the density of water, g acceleration gravity, and P atmosphere is the atmospheric pressure. Now question number 2. Yes, question number 2 is a jet of water with a velocity v strike a stationary flat plate at an angle theta. If the force exerted on the plate is F, then the rate of change of momentum is option A rho a v cos theta, option B rho a v sin theta, option C rho a v, option D rho a v cos theta plus rho a v sin theta. Very simple question. So please just you try to solve the question and write your answer in the chat box, and after that we'll, okay, once you try, then after I'll try to solve. So I'll give you 2 minutes, so within 2 minutes please just try to solve. So question number 2, please everyone, please just try to solve the question number 2. uh, I'll give you 2 minutes, so within 2 minutes please just try to calculate. After that I'll show you the answer and I'll solve also. Okay, so now I'll solve the question. A water jet, so you have one water jet, the water jet flowing from the nozzle like that. Now the velocity v, here velocity is v is given of water jet on a stationary flat plate at angle theta. So here the stationary plate is there and the angle is theta. So it is inclined, remember please, not vertical, not, it is bit inclined like that. Okay. If the force exerted on the plate is F, so due to this your water jet, the force is exerted by F, then the rate of change of momentum is, so what is momentum? Mass into velocity. This is momentum. Question is asking about rate of change of momentum. Rate of change of momentum means T, means m dot v. So now how we will calculate, let me just show you. So here you have the rate of change of momentum or force, the similar thing exerted on the plate due to the component of jet velocity normal to the plate. F is equal to rho a cos theta. If it was, let us suppose this is not the incline, if it is vertical, then what will happen? Only the rate of change of momentum will be rho a v. Rho a v. This is not rho a v. Rho a v square will be there. Okay. This will be your force. If this is velocity of the plate is stationary, if the velocity of the plate is moving, then you need to write this in terms of relative velocity, rho a v minus, if this is your velocity of plate, vp square. So this will give you the force. So remember please. Now the next question is question number 3. In a fluid flow, if the mass flow rate through a pipe is q and the velocity of the fluid is v, what is the total momentum flux through the pipe? Question is asking about total momentum flux. So now you have four options. A is equal to q into v, B is equal to q into v square, C is equal to rho qv, and D is equal to rho v cube A. Remember please, this is mass flow rate. Mass flow rate through a pipe is given q. Okay, so just think on that and try to give your answer within 2 minutes. So okay, I'll give you 2 minutes. Okay, so the question is asking about the what is the total momentum flux through the pipe if the mass flow rate through the pipe is q and the velocity of the fluid is v. So what will be the your total mass flow rate? So it is total momentum flux. Again it is asking about the force. So total momentum flux is nothing but rho qv. So I think question have slightly here the mistake in the written. This is flow rate, I think it is given, the not mass flow rate. So if you will write this rho a v into v, so you will get rho a v square. So this is your flow rate, not mass flow rate. Mass flow rate means what? Mass flow rate is m dot, which it is rho a v. This is mass flow rate. Mass flow rate is rho into q. This is mass flow rate. So if it is mass flow rate, so if this at the place of q, if it is was the m dot, at the place of q if it was m dot, so your the final expression will be your m dot into v. This will be the correct one, but here q it is given. Q means the flow rate, not mass flow rate. Okay. Here it is written, just here you can see rho v square a means rho v v a. So rho v q, or you can say write rho q v. So here q is equal to area into velocity, so this is flow rate. Okay, so slightly mistake, no issue. So let us move on the next one. Next question. Next question is, consider a 1.5 meter tall man standing vertically in the water and completely submerged in the pool. Determine the difference between the pressure acting on this man's head and toes in kilopascal. Consider the depth between the top of the head of the man and the free surface of the water is negligible. So just you try to write your answer. You have the four options. So for this question you can take 3 minutes. So bit calculative. Also you need to have concept of the your hydrostatic. So I'll give you 3 minutes. Within 3 minutes please just try to calculate. After that I'll explain you very well. Okay, so let me explain you. So consider a 1.5 meter tall man standing vertically in a water completely submerged in the pool. So I'll draw here one water body and one man is standing here. So it is like that. One man is standing here and the height of this tall man is 1.5 meter. Determine the difference between pressure acting on this man head and toes. So here this is your head and this is your toes. Okay, in kilopascal. Consider the depth between the top of the head of the man and the free surface of the water is negligible. So here negligible, there is no difference. So means the at the free surface the head is, means the head and free surface are almost same. Okay, so now we need to calculate here. So one thing you know, the pressure is equal to rho gh. So rho is 1000 because it is water, 9.81 and 1.5. 9.81 and 1.5. So just calculate what we will get. So here your the gauge pressure 0 and here p toe is the height up to the toe is this. So finally you will get, let me just show you the answer. So rho z h, because height is 0 so 0 it is written. So finally you will get 14715 Pascal. In kilopascal it will be 14.715 kilopascal. So this will be your correct. So option D will be correct for question number 4. So hope you understand. Very easy question. You need to understand the concept. Now the next question is question number 5. Again very simple question. So which of the following assumption is incorrect in deriving the Bernoulli equation? The flow is rotational, the flow is ideal, flow is steady, and the flow is incompressible. So you have 4 options. So just think please, just recall your concept and try to write your answer in the chat box for this question. I'll give you 2 minutes. Just recall your concept. Okay, so let me explain you. So incorrect. Here question is asking about which one is incorrect. Bernoulli equation assumption. So flow is rotational, flow is ideal, flow is steady, flow is incompressible. Which one? You have the four condition. So here incorrect is flow is rotational. So to derive the Bernoulli equation, several assumptions are typically made. This include inviscid flow. The flow has no viscosity, meaning there is no internal friction between the fluid layers. Next, steady flow. The flow parameter, velocity, pressure, density, etc. do not change with time. Incompressible flow. The fluid density remain constant. Along a streamline, the equation is applied along a single streamline. This is also your assumption. Now no external work, so no external work is done on the fluid and no heat transfer occurs. So this is also one of the assumption. So remember please. Now the next question is, okay, so here question is answer is visible, but I'll explain you how. So if the pressure in the main pipe of city at a particular location is 290 kilopascal, yes, determine this main can serve water to neighbors that are 28 meter above this location. So so let us assume you have one here the water pipe like that, and this is your mountain, and here you have your home like that, and this is your 28 meter above 28 meter. Now determine this main can serve water to neighborhoods that are 28 meter above this location, and the water pressure, let us suppose here water pressure is there, is the P is equal to 290 kilopascal. Now what, how much pressure need, if let us suppose this is your level, so from here to here how much pressure you require? So rho gh, so this is 1000, let us assume 10 and h is 28, so it is come 28, which is 280 kilopascal. So yes, if your pipe have 290 kilopascal pressure, and if your home is at 20 meter above the pipe main pipe, so yes, your home is required 280 kilopascal to reach water, and already you have the pressure in the pipe is greater than pressure required, so definitely it will be, the water will flow up to here. So remember, so this is the concept, very important. Now the next question is, or in the different way also you can solve. So how you can solve means your 290 kilopascal pressure can reach up to, means the how much height can attain by your water, how much height can attain if your pressure is 290. So how you will calculate, it is pressure is rho gh, so here is 290 kilopascal, so pascal in 1000, so here 1000 into 9.81 into H. So 3030 will be cancel out. H is equal to 29.9.81. So it will be your 29.56 meter. Yes, this 295 pressure can reach up to 29.56 meter. And if your home is, let us suppose if your home height is 30 meter, so you cannot, your this much pressure uh, not able to reach up to your 30 meter floor. So remember please, this is the concept. Now question 7. The pressure of a liquid measured with the help of piezometer tube is, you have 4 options. I'll give you 2 minutes. The atmospheric pressure, gauge pressure, absolute pressure, vacuum pressure. So please just try to write your answer in the chat box. The pressure of a liquid measured with the help of piezometer tube is whether atmospheric, gauge, absolute, vacuum. So now I'll show you the answer. So the pressure of a liquid measured with the help of piezometric tube is your gauge pressure. Remember please. So which is your gauge pressure. Now, so with the help of piezometer, generally gauge pressure is measured, and for the measurement of vacuum pressure manometer is used. Okay. So for measurement of vacuum pressure manometer is used. Atmospheric pressure and absolute pressure are measured with the help of Torricelli barometer and aneroid barometer respectively. So means if you are going to measure the atmospheric pressure, so you need to use the Torricelli barometer. If you are going to measure the absolute pressure, so you need to use aneroid barometer. Now next question is question number 8. So here determine the total water force in kilonewton acting on the bottom of a tank which is completely filled with water. Length, height and width of the tank is 2 meter and 2 meter and 3 meter respectively. So you have four options: A 115 kilonewton, B 111 kilonewton, C 117 kilonewton, D 121 kilonewton. So just please try to calculate and try to write your answer in the chat box. So I am waiting. So I'll give you 3 minutes for this question. So because this is a bit calculative, so just try to calculate. First try to think and then try to calculate the question. Okay, so let me explain you. So here you need to calculate, determine the total water force in kilonewton acting on the bottom of the tank. You have tank like that. Okay, completely filled with water. Is completely filled with length, height is 2 meter, length is 2 meter and width is 3 meter, like that. You have, this is your 3 meter, completely filled with water. Okay, now so here you need to calculate the total water force. So water force you need to calculate. Total. So total pressure by area. So what is total pressure? Rho GH means this height divided by area. Area is which area? Your area will be, let me just draw very clearly. This area will be your okay. So area is, so here is your area. Now you can calculate very well. So here it is rho gh. So rho is 1000, 9.81, h is 2 meter. So your pressure is 19.62 kilonewton per meter square. Now what is area? So area is this 2 and 3. So I'll just write here with figure, so you will feel little bit more understanding. So rho 1000, 9.81 into 2 meter divided by 2 into 3. So 2 will be cancel out, and after the calculation what we will get, 117.117, 1 round of 117 kilonewton. So this will be your correct answer. So option C will be correct for question number 8. So hope you understand. Sometimes you can don't just remember why we are taking this surface area, the bottom one, because of the question is asking about total water force, means, or you can say the maximum water force. So maximum pressure will be at this location, at the bottom surface. So that's why we are focusing on the bottom area, remember. Next question is question number 9. Question number 9 is the area of jet and velocity of jet are 0.2 meter square and 75 meter per second respectively, and the total discharge through a Pelton turbine is 3 meter cube per second. What are the number of jet required? So option A 4, 3, 2, 1. So just try to calculate and try to think. For this question I will give you 5 minutes, because this is very tricky question, and also concept is also there. So just try to calculate please. Okay, so let me explain you. So you have the area of jet. So let me just draw here. So the water is jet formation through the nozzle is there. So area of this jet is 0.02 meter square, and the velocity of this jet is given 75 meter per second. Okay, the total discharge through the Pelton turbine is, okay, so here you have one turbine. Okay, the total discharge it is given through the turbine is Q is equal to 3 meter cube per second. Okay, what is the number of jet required? So means you, your Pelton will turbine or Pelton turbine have the discharge 3 meter cube per second. And what is the discharge of this single jet? So discharge is nothing but area into velocity. So what is area? 0.02. What is velocity? 75. So this will give you 0, 14. This is 14. Okay. So not 14, this is 15. 150 and here it is. So it is 1.5. So one jet, the discharge of a single jet is 1.5, and you need how much? 3. So how number? Nothing. So 3 by 1.5 means you need 2 jet. If you will have 2 such type of jet, then your turbine will give 3 meter cube per discharge. 3 meter cube per second. So remember please. Bit tricky but very important. So similar type of question you can expect in your coming exam, NPTEL exam or the competitive exam also. Now the next question is the difference in pressure head measured by a mercury water differential manometer for a 20 centimeter difference of mercury head. So here you need to calculate, and the specific gravity of mercury is 13.6 and density of water is 1000 kg per meter cube. Option A 2 meter, option B 0.22 meter, option C 2.52 meter, option D 2.62 meter. So let us read again the question. The difference in pressure head measured by mercury water differential manometer for a 20 centimeter difference of mercury head will be. So here you need to calculate the difference in pressure head. Remember. So just think, for this question also I will give you 5 minutes. So please just try to think and try to calculate the answer for this question and try to write your answer in the chat box. Okay, so let me explain you. So the difference in pressure head you need to calculate in this question, and which is measured by mercury and water differential manometer for a 20 centimeter head, or difference of mercury head will be. So here you have in the question is not very clear written. So here you need to calculate the difference in pressure head, and the data is given the 20 centimeter your mercury water differential manometer head is 20 centimeter difference is there. So how we will calculate? So here one formula is there, very simple. So it is like that: H is equal to x. The what is x here? The difference of mercury head in mercury water differential manometer. So this is your x, which is given 20 centimeter, means 0.2. And what is rho m? Rho m is mercury, so rho of Hg, this is your mercury. So 13.6 specific gravity is given. What is specific gravity? It is nothing but rho of your Hg, if it is a specific gravity of Hg mercury, and rho of a standard fluid. Standard fluid means water. So rho of Hg will be what? If this is 13.6 and the standard fluid density is 1000, so you will get 13 point. So what you will get here, it is, I think some mistake is there. So 13600 kg per meter cube you will get, and the water you know already. So the water density, so once you will calculate these things, what you will get, let me just show you after putting the data. So finally you will get 2.52. so 2.52 will be the, your option C will be correct here for question number 10. Very simple question. So now I am going to take 5-minute break, also you can take. So the question number 11 is visible on screen, so you just try to calculate. Question number 11 is there. Okay, so now let us solve the question number 11. So question number 11 is a cylindrical tank with a height of 10 meter is filled with water. The pressure at the bottom of the tank is 200 kilopascal. What is the height of the water column in meter if the atmospheric pressure is 100 kilopascal? So this is 2 marks question. So you have option 5 meter, option B 10 meter, option C 20 meter, and option D 30 meter. So please just try to calculate and try to think how we will approach this question and write your answer in the chat box. So for this question I will give you 5 minutes. Question number 11. Okay, so now let us solve. A cylindrical tank with a height of 10 meter is given. So let me just draw a cylindrical tank here of height is 10 meter. So this is a cylindrical tank and height is your 10 meter. Okay, filled with water. The pressure at the bottom of the tank is, here it is given, 200 kilopascal. It is not given whether it is gauge pressure or absolute pressure. So now what is the height of water column in meter if the atmospheric pressure is 100 kilopascal? So here atmospheric pressure is 100 kilopascal. So if this is absolute pressure, your P, if your P is the absolute pressure, so what will be the gauge pressure, which is your rho GH? So 200 minus 100, so 100. And what is H from here? So rho and G will be this side. So H will be, this is your kilopascal, so we'll multiply with the 1000 for Pascal. So the rho will be cancel out here, 100 divided by 9.81. So it is almost 10. So let me just see whether the question is talking about the absolute pressure. If you will take, this is the gauge pressure, so your height will be 20 meter, which is not possible because the head is your here, the tank height is given 10 only. So the, so this, you cannot go with the 200 kilopascal because the height of the your cylindrical tank is 10 meter only. So if it is not in the question, it is given the absolute pressure, so you need to consider the absolute because of the height is only 10. So slightly less than almost 10, you can go through round off. So option B should be correct. Yes, option B is correct. So here you can see the detailed solution. The pressure at the bottom of the tank is the sum of atmospheric pressure and the pressure due to water column using the hydrostatic pressure formula. So P atmospheric, the similar question we have solved initially. Here you can see the similar question was there, this one, but here the height was S by 2. Here is your, you need to calculate the height here in the question. So the question number 10. Okay, yes, so here you need to calculate the height. Question number 11, not 10. Okay, so which is your equal to 10 meter, and the data is given in the question, you know, I have already explained you. Now the rearranging the formula, from here you can also rearrange, so direct you can also calculate the formula like that. P minus P at P absolute minus P atmospheric divided by rho Z. So this thing here it is written. So H is equal to, very easily you can calculate now. One thing is important, please, the correct answer is coming 10.2 meter, but you in the this your the MCQ, the your objective type of question, you need to select very close one or very appropriate one. So this is also you need to remember always when you are going to solve the objective type question. Next question is again very important question, so very interesting. Some figure is there, so let me just read the question first. The maximum blood pressure in the upper arm of a person is about 110 mmHg gauge pressure. If a vertical tube empty open to the atmosphere is connected to the vein in the arm of the person, determine how high the blood will rise in the tube. Make the density of blood is 1020 kg per meter cube. The 2 marks question. So just try to read the question very carefully and try to understand what question is asking, and then try to calculate. Let me read once again. The maximum blood pressure in a upper arm, here upper arm you can see, of a person is about, so your blood pressure is given 110 mmHg, gauge pressure is given, remember. If the vertical tube empty open to the atmosphere, this is open to the atmosphere, is connected to the vein. Here it is connected to the vein in the arm person. So here you can see this is the connected to the vein. Determine how high blood will rise in the tube. Similar question, you need to calculate the H only. Take the density of blood is 1020 kg per meter cube. At the place of your row of water, you need to consider the row of blood only, nothing. So just five. This is again the 5 minute question, 2 marks question. So you can take 5 minutes for this question also. Okay, so let me explain you. The here the blood pressure is, just imagine the pressure is given. So pressure is 110 mm Hg, means rho gh. So rho of your Hg is equal to your rho gh. This is your pressure. So this is your pressure. So here H value is given, what, 110 into 10 raised to minus 3. I'll write here because I'll write in the meter, and rho of Hg into Z 9.81. So this will be your 110 into 10 raised to minus 3 divided by, or if I try to say in other way, so the what will be the value of pressure? It will not go like that. So what will be the value of pressure if it is the mm of Hg is given, means, so rho of Hg into Z into H, what is the given here? So H is your 110 into 10 raised to minus 3. So now you can calculate the pressure. 13600 9.81 into 110 into 10 raised to minus 3. So this will be the your pressure in the Pascal. This will be your pressure. Now, so this much pressure you have. So this much pressure is equal to rho of blood G into H. H of the blood in the tube. So now this much pressure you have, rho B is 1020, G will be cancel out. Here G is also there 9.81, and here is also there. So let me write very clearly for your understanding. So 13600 into, I'll write G again here, not 9.81, because this will be cancel out anyway, is equal to rho of blood 1020 G and HB. So this will be cancel out from both sides, and 1020, if somehow if I try to if I assume this 1000 for the simplification of the calculation, so this will be your 13.6 into 0.11 is equal to your HB. And if it is, if I take this one is 0.1, so again it will be 1.36. So the answer will be somehow near about 1.36, but more than 1.36, but near about the 4.36. If I assume this 1000, if I assume this 0.1 is your 0.1 only, so again, so your answer is 1.46. So you can, if you will go through the very accurate calculation, so you will get. So anyway, here you can see very clearly. So this is 14675.76 is there, and after the calculation, the similarly whatever I am explaining, so similarly you will get H is equal to 1.46. Nothing hard. So now let us move on the next question. So this question was very practical actually. So you need to think very practically, then you need to understand the concept. Now the next question is also very important. So underground water is to be pumped by 85% efficient 5 kilowatt submerged pump to a pool whose free surface is 30 meter above the underground water level. The diameter of the smooth pipe is 7 centimeter on the intake side and 5 centimeter on the discharge side. Determine the maximum flow rate of water. So 2 marks question. Again you will take the 5 minute for this. So this is very important. So here it is, a figure is also there. Yes, so this is the figure for this question number 13, and option is also there. So 0.011, 0.0119, 0.0132, option D 0.0252. So this is a question. So 30 meter above the pool. So now you need to just see this question. So underground water is okay. Just first you try to calculate, then I'll explain you. 5 minutes you have. Okay, let me explain you. So underground water is to be pumped by 85% efficient. So here the efficiency is 85%, remember. The 5 kilowatt, your pump is 5 kilowatt to a pool whose free surface is 30 meter above the ground of the water level. So in the question is given, as you have seen, the diameter of the smooth pipe is 7 centimeter on the intake side and 5 centimeter on the discharge side. So determine the maximum flow rate. So here this is 30 centimeter. So intake side is your 7 centimeter and the outlet side is your 5 centimeter, the pipe diameter. So this much data is given. Power you have, power of the pump is 5 kilowatt and efficiency is 85%. So this much data is given. Now here you need to just think, the question is asking about the determine the maximum flow rate of the water. Maximum flow rate means discharge you need to calculate. Maybe discharge of your 7 centimeter pipe. Okay, 7 centimeter pipe, or you can also calculate because discharge will be the same for. So this much data is given. Now from the very beginning, what you know, the discharge is area into velocity. So is there is any relation here? No. So the answer is the in the data is given in the pressure. Pressure is 5 and what is not pressure, this is power. So what is power? Power is what? Work done per unit time. Work done per unit time. So is there any relation? What is work done? Force into displacement by time. And what is force? So like that, if you will connect the thing, then you can go up to the actual how you will actually approach the question. So you need to connect the like that. So now you can just see the here the solution. So the maximum flow rate, which is energy in the question is given. So what is energy? So energy is your 5 kilowatt. It is nothing but 5 kilowatt pump. So with the efficiency of your 85%, means you are not going to use, means your pump is not working what the 5 kilowatt will give you. So it is 85% efficiency. So you need to reduce, means if you are the pump is 5 kilowatt, so its efficiency is less than the 5 kilowatt. So here, so 5 kilowatt and the your 85% efficiency. Now it is rho QGH. So rho is 1000, Q is discharge, you need to calculate, G 9.81 and 30 is given in the question. Why? Because here you can imagine the potential energy is how much. The potential energy here is 30. So rho GH, this is your potential energy. But here the kilowatt is there. So the energy, the water flow energy is rho QGH. This is equal to your given the power. So after the calculation, what you will get? Q is equal to 0.0114. So this will be your correct one. So option A will be correct. So remember, such type of question is very easy, but try to think how we will connect the things. Like from here you can also go. From here So this is work done. Work done is nothing but energy per unit time. So energy per unit time, what is, so this will be your rho qgh. Energy per unit time is rho qgh. Like your, what is your mass flow rate? Mass flow rate is nothing but rho av, rho q. But what is your energy? So like force is equal to what? Mass into acceleration. What is work done? Force into displacement. So force is ma, not dot, ma d. So but here is the vertical, so mg d, right? And here the question is asking about, so let me just write here, then you can understand, I think. So here m g d by t. So this will be give you m, m dot. M dot is rho q g, and h is displacement, so means from where to where you are going. So rho q g h. So now you can think. So this is rho q g h is equal to your power. So hope you understand the concept and formula. Now let us move on the next one, question number 14. So at the base of the mountain, a mercury barometer read 700 mm, whereas at the top it read 500 mm of Hg. The density of air 1.23 kg per meter cube and is assumed constant. Determine the height of mountain. So again this is a very interesting question, very practical question. Question number 14. So just try to calculate. I'll give you 5 minutes for this. Just please try to calculate. These are the very conceptual question, little bit advanced. Okay, so let me explain you. At the base of the mountain, a mercury barometer reads 700 mm. Okay, so this is mountain. Let us assume this is the mountain is there. So at the base, at this level, your barometer gives the mercury. If I write the Hz height 700 mm. Okay, at the whereas at the top it read 500. Here it is similar instrument 500 mm. Okay, the density of air is 1.23 kg per meter cube. So rho of air is given 1.23 kg per meter cube. Now, and assume it constant throughout from bottom to top. Determine the height of mountain. So you need to calculate the height of the mountain. So h you need to calculate. So now just assume here, just think height of mountain you need to calculate. So the the barometer reading difference is 200 mm. So barometric reading difference is 200 mm. So how we will approach this question? Let me just show you. Here you can think like that. So it is 200 mm of Hg. So which is 0.2 mm of Hg. Now you need to convert this. The pressure difference due to air, the pressure difference due to mercury. So pressure difference due to air is what? The rho of air, Gg will be cancel out both side, and height is there. So and you can just arrange h is equal to like that. So finally you will get 2.211 kilometer. So this will be your height. Very simple, but you need to understand the thing. What? So pressure difference due to air is equal to pressure difference due to the mercury. So this is very very important. Now this is last question for today class. So question number 15. A rectangular plate 2-meter wide and 3-meter high is submerged vertically in the water such that its top edge is 1.5 meter below the water surface. Calculate the total hydrostatic pressure acting on the plate and the location of center of pressure you need to also calculate. So here you need to calculate two things. So question 15. So again you have 5 minutes, and then after I'll solve question and I'll close the today's session. So you take 5 minutes for this question. Okay, so let me explain you. So a rectangular plate you have 2 meter wide and 3 meter high is submerged vertically. So it is like that. 2 meter wide and 3 meter height. So this is 3 meter height and wide is 2 meter. It is like that. Okay. And 1.5 meter below the, this is 1.5 meter below the water surface. Okay. Calculate the total hydrostatic force acting on the plate. So you need to calculate total hydrostatic force rho g h into a. This is your total hydrostatic force. Now, and locate the center of pressure. Also you need to calculate the center of pressure. So two things here you need to calculate. Now very easy. So height, width and height is given already and depth is 1.5 meter below the. Now calculate the depth of centroid of the plate below the surface of water. So centroid will be HC, it is will be here, which is 1.5 and this is again 1.5, so we will get finally 3. Calculate the hydrostatic pressure. So hydrostatic pressure is nothing but rho g h of centroid. So h of centroid is what? H of centroid is 3 meter. So rho g and centroid, it will give you 29430 Pascal. Now calculate the total hydrostatic force acting on the plate. So force is equal to pressure into area. So area is 2 into 3. So it will be yours 176580 Newton. And calculate the location of center of pressure. It is center of pressure is nothing but your H1 plus H by 2 plus IZ AHC. Now what is, so for whole you can just write HC, no issue. So what is your IZ? This is your moment of inertia, second moment of area about the centroidal axis, because this is a rectangular here. So BH cube by 12, so you will get 4.5 meter 4, and HCP will be your, so 1.5 3 by 2, so this is whole 3 and 4.56 into, because 4.5 your IZ and A is 6 and SC again 3. So finally you will get 3.25. So hydrostatic pressure is this much and the location of center of pressure from the below of the surface, so it will be 3.25. So it is, this is your centroid SC and this is your center of pressure. So 3.25 and this is your 3. So remember please, your center of pressure little bit lower than your centroid. So remember here for this question. So okay, finally, so we have solved the all questions. So next class will be, let me just see, next class will be on 1st September. So we'll meet again on the 1st September. So for today, thank you from my side. Thank you all.